Welcome, my student, wherever you are. We have started a series of Kcse paper 2 sure bet questions. This one you will not miss them. I want to promise you around 30 marks in paper 2 that you are sure about. The grid below represent part of a periodic table. Study it and answer the questions that follow. Letters do not represent the symbols of the actual element. So whenever you have this grid here, you need to know how to label this one from number 1 to, so it means you must have the first 20 elements overhead. So you should know that this one is hydrogen, that's number 1, number 2, number 3, 4, 20. So these are the first 20 elements. So you are asked what name is given to the group of elements to which C and F belong. So C and F is here. This is C and this is F. So you can see that this is group 2 elements. So group 2 elements. This is group 2. So what name are they given? These are called alkaline. So the name is alkaline earth metals. These are called alkaline earth metals. Don't write alkali because alkali metals is group 1. So group 7 here, this is 1, 2, 3, 4, 5, 6, 7 here. Group 7 here, they are called halogens. They are halogens. So those are the things you need to know in the periodic table. And then remember that this is 1, 2, 3. This is period 1, period 2, period 3, period 4. Which letter represents the elements that is least reactive? Least reactive. The element which represents the least reactive is A. Why? Because A is in group 8, and we know that elements in group 8 they don't react because they are stable. They have electron configuration rate of 2 or 2 to 8 or 2 to 8, 8. So they are stable, they don't react. So it means that the answer here is A. But they forgot to write you explain, because you need to explain why you are telling it as you say that, because the element does not gain, do not gain nor lose electrons. In other words, you can say the element is stable. Electronic configuration of that element is stable, so it doesn't react. As simple as that. What type of bond formed between B and E? So you go back and look at B and E, the bond between B and E. So B is here, B is carbon, and then you can see that B is carbon and E is, this is number 16, that is sulfur. That is sulfur. So it is a reaction between carbon plus sulfur. These both of them, they are non-metals, so it's going to form CS. So what bond is between them? Both of them are non-metals, therefore they are going to form covalent bonds. They are going to form covalent bond because both of them are non-metals, therefore the bond is covalent. If the bond is covalent, you need to explain why. Because they are sharing of electrons. So you say they form, the reason is that they form bonds, by sharing of electrons. They form bonds by sharing electrons, and that is it. Write the formula for the compound formed when D and oxygen react. So you go back to D, you check which one is D. Which one is D? Let us go back to the table. D is number 13, and that number 13 is aluminium. Number 13 is aluminium. So aluminium, when it reacts with oxygen, they form aluminium oxide. Aluminium has got a valence of 3, oxygen has got a valence of 2. So they interchange, so we will have this one. So they will form aluminium oxide. And then you need to use the letters that were given. Therefore, it is going to form D, which represents aluminium, and then oxygen. So oxygen will put 2 here, and aluminium will put 3. So this is the formula of the compound that is going to be formed. This is the formula of the compound that is formed. On the grid, indicate with a tick the position of element G, which is in the third period of the table, and as G negative. So the charge is -3 and the period 3. So we go there to period 3. Period 3 is here. So this is period 1, period 2, period 3. So we see an element here that forms such as this aluminium will form positive. So that element must be here, number 15. So because 15 is 2 to 8 to 5, that is phosphorus. What happens during a chemical reaction? It is going to gain 3 electrons to be stable. So it is going to gain 3 electrons to be 2 to 8 to 8. Therefore, if an element gains electrons, it becomes negatively charged. So the element is in period 3 and it is number 15. Therefore, you indicate number 15. The element is here because it was element G. So number 15 here, you write G. So they said you like this. So that's where that element is. Study the information in the table below and answer the questions that follow. Substance H, J, K, L. We have the melting point. Melting point -17, 8, 78, 23 to 19. Boiling point is there. So substance H is very soluble in water, J is very soluble in water, K insoluble in water, L slightly soluble. The density of each of them has been given. This one is the same as this is 0, so it equals 0.077. This one is the same as 0.00133. This is the same as that. So it is important to analyze the table that you have been given. Which substance would dissolve in water and could be separated from solution by fractional distillation. You should know the conditions necessary for separating a substance using. So for these two substances, 1, they must have different boiling points. 2, the boiling point must be close to each other. So now water, we know the boiling point of water is 100, right? So this substance that we are going to dissolve in water and then separate using this formula, this method, it must be close. It must have a temperature that is different but close to 100. So you go to the table and check there. So look at H, it has a boiling point of 78, J -33, K 77, L 188. So the boiling point that is close to that of water is 78.78. Therefore H will dissolve in water because it is soluble. You can see it's soluble in water and then can be separated by fractional distillation because they have close but different but close boiling points. Therefore the answer should be H. Reason is that H has a boiling point of 78.5 degrees, which is close to that of water, hence can be separated by fractional distillation. Which substance is a liquid at room temperature, and when mixed with water, two layers would be formed. So two layers would be formed, which means it is insoluble. It is insoluble. So therefore K, you can see it is insoluble in water. So definitely this one is going to be K. So the answer is K, because you can see there it is insoluble. So if it does not dissolve in water, then that one is the best answer. It will form two layers. So the answer here is K. Reason is that it is insoluble. It is insoluble in water. Next question. Which letter represents a substance that is a gas at room temperature and which can be collected over water method? So a substance which should be collected from Form 1 should be slightly soluble in water. So that is the keyword that will help you. So go back to the table and check which element which substance that is slightly soluble in water. Then when you look at it, you find that L is slightly soluble in water, K is insoluble. The other two are very soluble. Therefore, the correct answer should be L, which is slightly soluble in water, because we know a gas that is collected by over water method should be slightly soluble in water. So therefore, this one gives us the answers. L, slightly soluble in water, because it is slightly soluble in water. Which substance that represent which substance by downward displacement of air, which can be collected by downward? So a substance which is going to be collected by downward displacement of air. Remember, downward displacement of air is upward delivery. Upward delivery. For a gas to be collected by that gas must be lighter than air. So if it is lighter than air, it means it is less dense than air. So let's go to the table and check which gas is there and is lighter than air. We have been given the density of air as this. So you analyze the density of air is 0.00129. So we go back to this one and check which one is less dense than that. So you can see L is 0.013 and that of air was 0.012. So this one is somehow denser. It is denser than air. L is denser than air. K is very dense than air. Look at J. J is 0.07, meaning it is less dense than air. So J is the collected gas that is going to be collected by upward delivery. So here the answer is J. Why? It is less dense than air. It is less dense than air because any gas that is less dense than air is going to be collected by upward delivery. So you can see now the way they combine a question and bring Form 1 work inside. So this is periodic table. It has gone to chemical families. From chemical family they have taken you back to Form 1. So you need to understand this concept from Form 1 to Form 4 in chemistry for you to be able to answer these questions. Organic chemistry question. That's another question that you must be there in paper 2. So give the name of the compounds that are shown below here. So which compound is this? First count the number of carbon atoms. Here we have 1, 2, 3, 4. So we have 4 carbon atoms. We have 4 carbon atoms. Now that one can be an alkane, an alkene, an alkyne, and alcohol or alkanoic acid. So what will tell you that what type of this one? You look at the functional group, what we call the functional group. So the functional group here is OH, and the OH is an alcohol. So if these are alcohol, then which name that is given for an alcohol with 4 carbons? Definitely it is going to be butanol, right? Butanol. So butanol is the alcohol, but is that the name? No. Look at where the functional group is. The functional group is on carbon number 1. Therefore the correct name is butan 1-ol. So butan 1-ol is the correct perfect name for you to score the marks. Look at the compound number Roman 2 it's given as COOH. So which compound is this? These are alkanoic acids. These are alkanoic acids. Then look at carbon numbers 1, 2, 3. These are 3 carbon atoms. So if there are 3, then that one should be 1, 2, 3. Therefore, remember the ethanoic acid, butanoic, propanoic. Therefore, this one is propanoic because 3 is propanoic. Then look at the next one, Roman 3. Which compound is this? When you see this compound written in this way, you should know that this one is an ester. You should know that this one is an ester. So esterification, the process is esterification. So which ester is this? Look at this is 1, 2. So the alcohol from which they combined with alkanoic acid is 1, 2. So this one is going to be, the name is going to be ethyl. It's called ethyl. Ethanoate. This is the process, is esterification. You need to know that. Describe a chemical test that could be used to distinguish between Roman 1 and Roman 2. So how can you distinguish? How can you differentiate between an alcohol and an alkanoic acid? How can you distinguish that? So describe a chemical test that can be used to distinguish between substance 1 and substance 2. Substance 1 is butanol and propanoic acid. So put the ethanol and put the alcohol and the alkanoic acid in separate test tubes. Add a spatula of sodium carbonate or sodium hydrogen carbonate to each of them. So effervescence will be produced or will occur in the test tube containing the CH, the alcohol, the alkanoic acid. Where the test tube with alkanoic acid, effervescence will occur. And the test tube which containing an alcohol, no effervescence will occur. And that will be able, will help us to differentiate that this one is an alcohol and this one is an alkanoic acid. So in alkanoic acids, effervescence is produced when you add sodium carbonate or sodium hydrogen carbonate. But a test tube containing an alcohol like butanoic acid, like butanol, there is no effervescence. In butan 1-ol, there is no effervescence. Study the information in the table below. Number of carbon atoms per molecule, relative molecular mass. Write the general formula for the hydrocarbon. In the table. So the general, we have been asked you to write the general formula, but look at here. So how will you tell that this is the general formula? tumepewa kuna number 1 iko na carbon mbili, so carbon mbili, each carbon inakuanga na 12, so that is 24, sawa. But the total mass is 28, so 20 ukitoa hiyo itabaki 28 minus 24 itabaki 4. So inamaanisha the hydrogen there are only 4 of them. So which element, which organic compound will be that? Will it be an alkane, an alkyne, or an alkene? So check. So if we put C2 here, then H4, that's what we have. Carbon ni mbili, hydrogen, so carbon 12 times 2 is 24. So inakuwa the mass ya carbon peke yake ni 24, lakini total mass ni 28. So yenye mebaki ni hydrogen na ni 4. Kwa hivyo this one. So which one is this? Unaona hiyo, like this one is ethene, which is C double bond C and then H. That is it. So the general point, the general formula for alkenes is CnH2n, and that is it. So we have known that these are alkenes. You can even do with the third one and confirm. Predict the relative molecular mass of the hydrocarbon with 5 carbon atoms. So 5 carbon atoms, you simply write C5H 2 times 5 from the formula. That one will give us C5H10. You just use the formula you have created there, and you will tell us that the second one is this. So we have been asked to predict the molecular mass. So carbon, if this is the form, the compound, then carbon, 1 carbon is 12 times 5 plus hydrogen times 1. So this one is going to be 60 plus 10, and that one will be 70. The molecular mass for the 50 carbon will be 70. Determine the molecular formula of the hydrocarbon for this one and draw the structural formula. So we will determine that. So that one is C5H10, and the structural formula is 1, 2, 3, 4, 5. And we put a double bond there. Here we will have hydrogen. There we will have hydrogen. 1, 2, 3, 4. Here we will have 1 hydrogen. This is the structural formula for pentene. And that is it. That is the structural formula for that. That is the structural formula for that one. Study the scheme below and answer the questions that follow. So when you are given this one, you need to, you can say this is alkyne. So 1, 2, this is actually ethine. This is ethine. So ethine will undergo step 1 to form. You can see this one is ethane. So ethane has been formed from sodium ethanoate. So from sodium ethanoate, this is a laboratory preparation of alkanes. So the conditions that we need here, we need soda lime, which we call sodium hydroxide. So that's what the condition necessary for ethine to move or to react to form ethane. The process is hydrogenation, addition of hydrogen. So here we need hydrogen, and then the conditions that we need there is the catalyst nickel catalyst and a temperature of between 150 and 250. So that is for step 1. Then step complete combustion. So when organic compounds undergo combustion, we know what they form. So if this one is going combustion, is going to form carbon 4 plus water. Then we have ethane to step 2. It is going to form 1, 2, there is a Cl here. So it means there is an addition of HCl. There is an addition of hydrogen chloride gas. So this one will undergo a certain process, step 3, to form this. What is this? This is a polymer. So the process here is polymerization. Polymerization. Now, before even you go to the questions, you need to analyze the diagram like that, and then you are able to answer the question. Name the reagents used in step 1. Step 1, we need hydrogen. So in fact, excess hydrogen will take us to alkene and then alkyne. Step 2, which is condition we need hydrogen chloride. We need hydrogen chloride gas for step 2 to occur. Step 4, what reagent? So here we have not asked the conditions. The next question now will be the conditions. What are the conditions for step 1 to occur? What are the conditions for step 2 to occur? Now, I already have said for hydrogenation, we need nickel catalyst and a temperature of 150 to 250. So that one here, this question has not asked that, but it is important you know. Hydrogenation, step 4. Which one is step 4? Step 4, that is the formation of alkanes in the lab. Laboratory preparation of alkanes, we need the soda lime, and that soda lime is sodium hydroxide. Sodium hydroxide. Explain one disadvantage of continued. Before that, write an equation for the complete combustion of this. So this one is C2H2 plus oxygen. So this one is going to form carbon dioxide. An organic compound undergo combustion to form carbon dioxide plus water. So we need to balance this equation. We have 2 here, so we put 2 here, we put 4 here, so that this one now becomes hydrogen here. They are put 2 here to remove this odd number here, 1, make it 2, and then this one is 8 plus 2, which is 5. And that one is now balanced. You liquid, gas, and this one is a gas. Explain one disadvantage of continued use of items made of compound formed by step 3. Compounds formed by step 3, we go back to step 3 and check which compounds are that. So step 3, these are, you can see these are polymers. So it is a polymer. If it is a polymer, what disadvantage do you know about polymers? Polymers has got one main disadvantage. It is that they pollute the environment because they are they don't decompose. So they don't decompose. They are non-biodegradable. So you just write that environmental, they cause environmental pollution. They cause environmental pollution because the items are non-biodegradable. Non-biodegradable, in other words, is that these items, they don't decompose. Therefore, they cause environmental pollution. Another sure bet question we want to look at is electrochemistry. Electrochemistry question will not miss in any chemistry exam. So electrochemistry. Electrochemistry. We need to look at questions in electrochemistry. Look at this question. Use the standard electrode potential for element A to F given below to answer the questions that follow. Elements do not represent the actual symbols of elements. Now you see A plus, this is equation like this. You can look at these equations. Now I want to tell you one thing, that the most positive and the most negative will produce the highest EMF. So when you look at this element F and element A, because the most negative is A, the most positive is F, this one, when you combine them, they will give you the highest EMF. When you see C is 0, 0, and that one is our reference, and that one we know our reference electrode is hydrogen. And then you need to know that the more the negative, the more the reducing agent. The electrode potential with the higher negative value is more reducing power. It is more reactive. Therefore, it will give electrons. The more the positive an element is, the more the oxidizing agent it is. The more the oxidizer it is, the less willing to give electrons, so it will undergo reduction. Which element is likely to be hydrogen? Give reason for your answer. The element that is likely to be hydrogen is C2. Why? The reason, hydrogen, we know that hydrogen is a reference electrode. Is a reference electrode whose E standard value is 0.00 voltage. So we know that. So whenever you see the one which is 0.00 volts, then it tells you that one is hydrogen and it is the standard electrode potential. Which is the E standard value of the strongest reducing agent? The strongest reducing agent, I have told you, it is the one with the most negative. So you can see the most negative, they have one E, so that is negative 2.90 V. That is the most reducing agent, right? In the space provided, draw a label diagram to obtain C, when B and D combine. B and D combine. Now we have been told B and D. Now look at B. B is negative 2.38. D is positive 0. So it means when we are going to draw, B is going to give electrons, D is going to receive electrons. So you draw electrode, you put the electrode into and then you remember to draw the salt bridge. You draw the salt bridge, and then you draw the electrode in this side. Then you remember to draw the voltmeter here. Once you have drawn that, the most important thing is to tell us what is inside here and which one is going to be B, which one is S. And the name this one is the salt bridge. So if I say that this one is B, then the solution inside here should be P positive, the ions of that. And if that means this one is going to be D, and the solution here should be D positive. Then the electron should be moving from where to where? From B to D, because B is more reactive. It is going to give it is the one that is going to give electrons, and this diagram is completely perfect for you to get 3 marks. The next question is to calculate the EMF for the cell above. So this one is EMF is equal to E standard of reduction minus E standard oxidation. We have said which one will undergo oxidation. B will undergo oxidation, D will undergo reduction. So you go and write the E for the reduction was positive 0.34 minus into minus. That one for this one was negative 2.38. So this one is the same as 0.34 plus 2.38, and that one will give us 0.272 volts, and that is the EMF for this cell. During electrolysis, 2 amperes were passed through. Write the equation for the, so we are reacting copper 2 here. So the most important thing is the copper ion. So copper 2, which is in solution, we add 2 electrons, it will lose this one to form copper metal. So that is the equation that you need to know how to write. Because it is in a solution, it is in ions form. So this one is aqueous. It will lose 2 electrons to form, it will regain 2 electrons to form this one. So it will undergo what we call, this is reduction. It will regain 2 electrons to form copper. Determine the mass and the anode, the mass at the anode. But we know before we go, we must get there. The quantity of electricity will be equal to I times time. I represent the current, so the current is 0.2 times time, which is 5. We times 60 to make it to minutes. When calculating this one, time must be in seconds. Time is a must to be seconds. So when you multiply this, you get 3600 coulombs. When you multiply that, you are going to get 36 coulombs. But we know that 1 Fahrenheit is equal to 96,500. But copper, it has 2 Fahrenheit. The charge is 2, so it means it has 2 Fahrenheit. 2 Fahrenheit will be what? 2 Fahrenheit will be 193. This times this, it will be 193.00 coulombs. So 193 coulombs has a mass of 63, because that's 1 mole, which is equal to 63.5 grams. So we will ask, what about 36 coulombs? How many grams will it be? So you multiply, so that is 36 times 63.5 divided by 193, and this one will give us a mass of 1.18 grams. Let us look at chemistry paper 2. The first question is from organic chemistry. I give the systematic names for the following compounds. You have been given the first compound here. You need to look at it and then identify which type of compound is this. You look at this from C to here. You can see the functional group is RCOOH. So that tells you this is an alkanoic acid. The next thing, after identifying that this is an alkanoic acid, then you count the number of carbon atoms, 1, 2, 3. That tells you that this is propanoic. Propanoic acid. That tells you that one is propanoic acid. The next compound, you look at this, and whenever you see CH and there is double O, excuse me, double O in between, then you should know that one is an ester. The process of forming this one is esterification, where an alcohol is reacting with an alkanoic acid in the presence of concentrated sulfuric acid. So this compound here is this. We start from here, 1, 2 ethyl. This is ethyl. Ethanoate, 1, 2 ethanoate. So the alkyl part comes from the alcohol and the alkanoate part comes from the acid. Then the last one, the third, number 3, here when you look at this one, you may not tell exactly what it is. So we don't know whether this is an alkane, an alkene, or an alkyne. What you do, count the number of carbon atoms, 1, 2, 3, 4. Write the structural formula for that compound. Once you have done that, so put the hydrogen. That's the first carbon has got 1 hydrogen. The second one does not have any hydrogen. The third one has got 2. The fourth one has got 3. Now you are aware that each carbon atom must be surrounded with the 4 covalent bonds. So look at this one, 1, 2, 3, 4, it's okay. 1, 2, 3, it's okay, 4. And look at this carbon number 1 and number 2, 1. This one has got only 1, 2. What about this one? This one has got 1, 2. So what is missing? If you put a double bond, another dash here, a covalent bond, still this one will be 1, 2, 3, 1, 2, 3. So it means you had another one again. So we will have 1, 2, 3, 4, 1, 2, 3, 4. Therefore, this compound is an alkyl, I don't know, alkynes. It is an alkyne. Triple bond means it's an alkyne. Therefore, this one is now the double bond. The functional group is in carbon number 1. Therefore, we say but 1 ine, and that is the systematic name for that compound. The scheme below shows a series of reactions starting with ethanol. Study it and answer the questions that follow. So before you go to the question, you are supposed to analyze this chart, this flow chart properly, because you have read the concept, the content. Now look at this. We are starting with the ethanol. What does ethanol undergo to form ethanoic acid? This is ethanol. This is ethanoic acid 1, 2, ethanoic. Therefore, this one is oxidation. So step 2 is oxidation. What are the reagents that are used in oxidation? We know we use acidified potassium permanganate or 7 or acidified potassium dichromate. Those are the that we have talked about. Now let's go to step 2, step 3 here. Step 3, what's happening? Ethanol, 1, 2 ethanol is undergoing a certain step, forming 1, 2, forming ethene. This is ethene. So Which step is this? Step 3 is dehydration. Dehydration is the removal of water from a compound. So what has been taken away? This OH has been taken away to remain with the ethene here. So we have ethene dehydration. The conditions necessary for the dehydration to occur is conc sulfuric acid. Conc sulfuric acid. Step 4. Step 4. Ethene ethene is undergoing a step 4 to perform a polymer. This is K is a polymer. It must be a polymer. It is a polymer. Then we will know, of course, this is ethene. This is going to be polyethene. So the polymer here is polyethene. So K is polyethene. That one is obvious. Now let's go to step 1. This one, this is ethanoic acid. Ethanoic acid is reacting with magnesium. It reacts with magnesium to form products here. So this is an acid, remember? An acid plus a metal is going to form a salt plus hydrogen gas. So the product here is going to form magnesium ethanoate, magnesium ethanoate, magnesium ethanoate plus hydrogen gas. Those are the products. But when ethanol is reacting with magnesium or a metal, any metal, it forms magnesium ethoxide. Ethoxide plus hydrogen gas. So that is the difference. Ethanol will react with magnesium to form a salt called magnesium ethoxide, while ethanoic acid will react with magnesium to form magnesium ethanoate. So that is the difference. Now, step here, the ethanoic acid is reacting with sodium hydroxide to form sodium ethanoate. This one is sodium ethanoate. Sodium ethanoate is undergoing step 4 to form methane. This is methane. Methane is undergoing the process here in excess chlorine to form compound Z. So which step this process here where we use UV light is called substitution. Substitution, because we know alkanes does not undergo many reactions other than combustion and substitution, because because alkanes are saturated, therefore they don't have much reactions. So we are going to see compound Z. Compound Z is we are going to form excess. If it is excess, we are going to form CCl4, tetrachloromethane. We are going to form tetrachloromethane here. Then we have this one is heated methanol. We are using methanol and ethanoic acid. Ethanoic acid, not ethanoic, but ethanoic acid, yes, plus methanol. This is an alkanoic acid plus an alcohol. That process is esterification. We are going to form an ester, because in the presence of conc sulfuric acid, we are going to form an ester, and water is formed. So what will be the name? Because the acid, the alcohol is methanol, so we are going to form methyl ethanoate. This one is going to X is methyl ethanoate. Methyl ethanoate. ethanoate, which we will write CH3 COOCH3. This is an ester called methyl ethanoate. Methyl ethanoate. So ukishachambua namna hiyo, now you can go to the questions and try to see what the question required you to do. Name the type of reaction, the type of reactions and the conditions in step 2. So step 2, so we have said step 2. Step 2 here is oxidation. The conditions there, we need heat, that is temperature. Yes, so that one is oxidation. The condition is you warm. The reagents, now that is the reagents that we need. You can use acidified potassium permanganate. This H refers for is for acidified, or you can use acidified potassium dichromate stroke. So any of this one can work best. Step 3, type of reaction taking place in step 3. So we go back to step 3 and look at that. Step 3 is dehydration. The conditions necessary is conc sulfuric acid. So you see, you have done already finished. You are just copying what you have done. This one is dehydration. Reagent is conc sulfuric acid. You can simply write sulfuric acid, but you are told name the types of reactions, name. So you are asked to give the name. Please don't write the chemical, So like here, it is important you write acidified potassium permanganate 7, because that is the name. That is here. They consider that because they say the name. If they said identify, you can write another thing. But for the name, here write, this is warming. Here you write acidified potassium manganate 7. So here is sulfuric acid. It is important you know that whenever you are asked to give the name, it should be the name and not the chemical symbols. So this one is conc sulfuric acid. So the condition, we need a temperature. Temperature of 160 to 180 degrees Celsius. Whenever you ask it to name, give the name and not otherwise. Write the equation for the reaction taking place in step 1. Step 1. So we can look at the reaction in step 1. So what is in step 1 there? Step 1 is ethanoic. So step 1 is ethanoic reacting with magnesium to form magnesium ethanoate. So this one is simply CH3 . Kcse. So that is the equation that you are required to write. Name the product X. X is methyl ethanoate. We said that is the ester. Methyl ethanoate. Identify the process leading to the formation of compound Z. Compound C, actually that was substitution. So we say the compound Z. This is where we had compound Z from, that is substitution. We said here is the substitution, and that is the process of forming compound C. And the compound C, because they are using excess chlorine, then it is going to form tetramethane, tetrachloromethane. Identify the process. The process is substitution. Substitution. Name compound K and state one of its uses. Compound K is a polymer, and we say that polymer is polyethylene. So what are the uses of polyethylene? Uses of polyethylene. So name the polymer is polyethylene. Uses are many. Used in the manufacture of plastics, pipes, manufacture of paper bags, plastic bags, used in the manufacture of insulators, and many others uses. The so that is 12 carbon. One carbon is 12. There are 2 of them. Then plus hydrogen, there are 4 times 1. So we will have everything 2 times n. This is 24 plus 4, so we have 28n will be equal to the total mass, which is that 9,200. So 28n is equal to that 9,200. You divide by both sides by 28. So n will be 1,400. So there will be, in this compound which contains this mass, there will be 1,400 monomers that will form this polymer here.